So I have a good news. I talked to university. We are gonna have a TA. So I send a message to him. So he will. I will talk to him and probably he will finish what I started. Next week you are gonna have all your quiz, homework, midterm. So great, ready. And then I will ask him for like office hours. Like at least you have 1 or 2 office hours before final. Sounds good?
Sounds good.
Okay, great. Okay. So today we have something. I'm trying to finish, like you remember, I start talking about dynamic programming, and then I talk about how to solve that one of the problems. And now I'm going to talk about coin chain, which is a really, really famous problem. What I'm going to do, because I want to do it as a quiz, but I'm going to teach it. I'm doing quiz, but not a individual quiz. I make a break room. So, and then what you are gonna do, people in that break room trying to solve it, and then you will upload it to Canvas. Does it make sense? I just want to, because you guys most of the time are quiet in the class, I want to engage, to just write that one down and just try to upload it.
Sorry, I couldn't really hear you. Could you repeat that?
Yeah, can you say that again? I'm sorry.
What? You didn't hear it too?
No, I couldn't hear it.
Yeah, and now how about now? Interesting. That's the same microphone I use every day. So, is it better? Okay.
Yeah, I can hear you.
Okay, so I started dynamic programming. So we are gonna finish the question that we started. So you remember I talked about like binomial coefficient. So we finished that one, and then I'm gonna start talking about coin changing, which is a really, really famous problem about how to do the coin change. And then I will explain some steps. And then there are 2 examples. I wanna have a break room. So you're gonna be divided to break room, like 4 or 5 of you guys gonna be in one break room, and then you will try to help each other solve that problem, and then you are gonna upload it in Canvas. Does it make sense? I want you to get engaged in class, because you're most of the time you guys are so quiet. Is it clear? It's like a quiz for today. But it's not an individual quiz. You can do it together. Okay.
And then how much time will we have?
What did you say?
How much time will we have for the quiz?
It's like with 20, 25 minutes. It's easy. I'm just gonna explain it myself, and you guys gonna try to solve it together. So it's not gonna be hard. So you will talk to each other, write it in paper, probably, and then you will upload it to Canvas. Does it make sense?
Yeah.
So, okay, let me go back. So, and then as a reminder, what we did yesterday, and then let's finish that one, and then let's start talking about coin change thing, and then you guys can start the quiz. So, and then more engaging class. Okay. Let's see. Okay, I talked about this problem, how to solve it with dynamic programming. So we start talk about it. It's like, okay, let's calculate everything. So N and K, we got this one. What was the first step we did? We say, okay. We say, okay, if K equal to 0 or K is equal to N, then what do we do? So next step is gonna be, we are return 1. And the next step, what's going to happen? If that's not the case, so that's what we are gonna do. We are gonna return. So as we showed yesterday, we are gonna call this function again. This time we call it for N minus, let me write it a little smaller. So it's gonna be at least in one row. And, so what is going to be? It's going to be n minus 1 and k minus 1 plus next one of n minus 1 and k. You remember, I draw that graph and you see there is some, we say, okay, let's just start with this one. And then what is going to be? Tell me. Based on this one. What is this 2? This 2 is this summation. How do you kind of just let me know what is this next 2? It's easy. I already, okay. The first one is going to be k minus 1, n minus 1. And then this one, what is this one? It's going to be, okay, n minus 1, k. How about next step? Let's do the next step. What is next step for this one? Right, n minus 2, k minus 2. And what is the other one? Okay. No, this is going to be, because this one is k minus 1. Okay. It should have stayed k minus 1. Okay, k minus 1. And how about these 2? Okay, great. N minus 2, k minus, I'm so sorry, this one is 1. It's written really bad. My k minus 2, k, n, okay? And next one is going to be, okay, great. Let's go one level down. What about this one? And try to write it really clean. So how about this? Okay. What is this first one? Okay, great. N minus 3, k minus 3. How about the other one? N minus 3, k minus 2. Great. How about next one? N minus 3, k minus 2. So this is going to be n minus 3, k minus 1. Okay, let me make this a little bigger. N minus 3, k minus 1. And okay, sounds good. This is going to be n minus 3, k minus 2. And how about the next one? Next. Yes, correct. N minus 3, k minus 1, and the last 2. N minus 3, k minus 1. And then the last one, which is going to be done. So it's going to be n minus 3 and k. So as you can see, I just got to here. It means in every level, if you look at the last bottom, so this first one is not, I calculate this one. If I calculate this one, n minus k minus 3, I do have some repetition. This one, this one, this one, they are repeated, as you can see, this one, and this one. It means if I calculate it one time, I can use it next time, but I can use it when, if I just keep it. If I find it, if you can think about, I'm just running it on memory. If I don't keep this one, it's going to be gone. Next time I need to calculate it. It means I need to keep this one or this one. You can see these 2, actually these 3 too. This 3 is like repeated 2. But if I don't calculate, don't keep them, still that's gonna happen. Next time when I'm coming to this point, I need to calculate this one. That's the only thing I remember. You remember, I showed it like table and explain why we need to fill that table and keep it. And the name of the table was like memorization. So, but here, how we do this one? I said, okay, now I don't write the table anymore. But how is like, this is, you can see, this we write it like this. This is really hard because you need to calculate everything one by one. But if I want to write a pseudocode based on this table, you remember I just write a table for you guys. So, okay, this table is going to work out like this. How we write that table? So let's do the table again. I need to do it again because based on this table, we are going to write the pseudocode. Let's write the table and you guys tell me how to fill it. Let's do it like this. This is a start 0. I want to go all the way 1. This is 2. Let me put 3 here too. And then 3, it means it's here. And then I have k minus 1. And last one is k. Oh. Okay. Sorry. This part is 0, 1. And then I do 2. Then I do 3. And then again. And then what do we have? We have n minus 1. And the last one is going to be n. You see, I do have this table. Now, let's do this thing. The last part, that's the one we want to calculate. This is the one, it's going to be k from what? Let's make it a little bigger. This is the important one we want to calculate. We say constant. Oh, I forgot this one. Bummer. Okay, this is going to be what? This is going to be k from n. If I go one step above, let's make it like this. One step above, this one would be what? N minus 1 k based on this. And then, okay, let's see what's going to happen. Tell me what's going to happen for the other one. Let's calculate all of them. So for example, 0, 0. If I have 0 from 0, what is going to be this one? This is going to be number 1 because it's 0 by 0. This is going to be, we fill this one with 1. How about this one? Let's see, for example. This second one, this is, oh my gosh. This one was 1. Let's do this one. This is going to be 1 from 0. What is this number? But the way we calculate it in math, we say, okay, let me write it here so you don't forget. This is k, this is n. The way we calculate it in math is like n factorial, k, n minus k factorial. That's the way we calculate it. Am I right? This is a definition. Okay, let's see. If I want to calculate this table, this one, the second one, we say, okay, 1, 0, I write it. It's 1 factorial, and then 1 factorial. This is gonna be 1. So I put this one 1. I will keep it for the next time. Let's do 2. If I do n, any n, and this one is 0, the first row, because this is gonna be n factorial, this is gonna be 0, and this is gonna be n factorial. It doesn't matter. All of this first column is gonna be 1, all the way. It's gonna be dot. So this is all the way down. This is gonna be 1. That's the first one. How about if we go more down? For example, about this one. Okay, if this is 0 and this is 1, it means everything. It means if k is greater than n, all the time, because it means that this part, k is greater than n, since the denominator is going to be bigger, so every time this number is going to be 0. Anything, it means anything above every number is higher than, if k is greater than n, every time is going to be 0. Does it make sense? It makes sense if I consider this diagonal, everything above the diagonal is going to be 0. This is going to be 0, 0, 0, 0, because they are above diagonal. Diagonal is where they're all equal. Everything above that one, it means k is greater. So if I calculate this one, when they are equal, if you have n and k is equal, which is going to be diagonal, it's going to be 1. So this is going to be 1. This is going to be 1. Keep going. So this is going to be like n minus 1. A minus 1. Still, this is going to be 1, 2. I just put it here just for as a reminder. This is going to be n minus 1, k minus 1. This is going to be 1. Everything, actually, this is going to be like 3 dot. Everything here is going to be 1. Anything above this is going to be 0. Doesn't matter what is it, because they are going to be like, and anything under this one, you need to calculate. For example, this one. If I do 2, 1, this is going to be 2. So this is going to be 2. And then how do you do this? You just, for the next one, let's see. That all the thing I'm trying to explain, you need it for the quiz too. I'm trying to find a pattern to write the pseudocode for it. So for this one, the next one, what is that? Next one is when we have 3 and this is 1. This is going to be 3. It means these two numbers, the summation is going to be here. This is going to be 3. This one or 2, because this is the previous one. For example, for this one, you need these 2. Here you need 2 previous. So this 3 is going to be 2, 1. For this one, it's going to be 2 and 3. This is going to be 3, 2. You just keep going like this. This is number 1 because it's diagonal. If you keep going, you see this one, 3 and 1 and 3. This is going to be 4. You're just doing like this. Now, based on this structure, I see I have a table. And you see, for example, for finding this number 3, you don't calculate these 2. You already have them in a table, so you use them. So if I want to write the pseudocode for dynamic programming of this problem, instead of like solving it like in divide and conquer. So how do you write it? Let me write. Is it clear? You guys understand how I fill that table? Okay, so if you get it, so what is the first step? How do I do this one? What was the first thing I calculate? So what was the first thing I calculate? I calculate this one. I need this one. If I don't have this one, I cannot go down. You can look at this one. 1 and 0, 1. 1 and 1 is going to be 2. This is 1 and 0 is going to be 1. This is a calculation. So, okay, let's go about the table again. One of the students asked. The way we calculate, we just put K here above the table in the row, in this column, and row is going to be N. How do we calculate? We want to find this one, K from N. So for finding this one, I go one step ahead, K, N minus 1, and then this column is going to be K minus 1, N minus 1. As you remember, based on the formulation, if you want to find Kn, you need to do this summation, this and this. I just write it here. You see, this and this. So it means if you, for any part of the table, you need to have this one and find these two. So I start from here. It's like a 0, 0 doesn't have anything about it. So I need to have it. And for the other, I say all the things on the diagonal is going to be 1 because n and k is equal. When they are equal, so it's going to be 1. And anything, if k greater than n, is going to be 0. So you can see. And the others, I just calculate them based on the previous table. Look at here. This, and then I know the first column is 1, 2. That's the first thing. So first of all, I know C0 is 1. This is the first one. C0 is 1. And then I'm going to go through all the layers. How am I going to do that? I say, okay, for I, if I want to, for I1 to K, I need to do this thing. See? For I1 to K, what I do, all the CIs is 0. You see? Because first one was 1, the other all the way from here to here, from 1 to K is 0 because they are bigger. So then I just found the first row. What I'm going to do for the next second. Now I do another row. How I do it? Let's do the second row. From J to N, 2 things I calculate, this one and this one. If I have these 2, the first one, first row and the first column, everything is done. For example, why? Because I already have these 2. For calculating this one, it's like 0 plus 1, this is going to be 1. So I go 1 step down. 1 plus 1 is going to be 2. For next one, 2 plus 1 is going to be 3. 3 plus 1, 4. And that's going to go down. So I just say J from 1 to N. I calculate it. And then what I'm going to have is from K to down to 1. So what I'm going to do, I have J from here to N. And for K, if I do 1 step from K1 to down to 1, like CI is going to be CI minus 1 plus CI. I put it, yeah, I'm so sorry. This is going to be another, let me see. I put this one I from K to 1, you know, from J started here, go to down, and K from N to here, because it's going to be the other way. If I get, and this is going to be CI, like here, CI minus 1 plus CI. So I just do this summation and go down. So if I do have this one, then at the end of the day, this is going to be 5, this is going to be 6, and then 7. What's going to be 7? Return CK. I just need to return this one. Does it make sense? Okay. If that makes sense, so it means instead of just, you see how easier it gets. Because every time I just have the previous 2, I just do this summation, go level down, and then do these things and return the CK at the end. It means instead of just doing all these layers, what I did, I calculated based on this one. You see, there's one thing you need to remember. When I'm trying to do, like, I want to teach you something for finding a runtime. Finding a runtime when you solve this for loop. It means how many times you're going to read this. This, like, for example, the cost for this one is 0 because you don't read it a few times. The cost for this for loop, because you are calling it K time, is going to be theta of K. It means you're calling it K time to do this one. It's going to be theta of K. This, the other one, I call the first loop for loop N time. I call the second for loop K time, because this is going to be together. This T3 is going to be theta of NK. So if I do all this summation, this one is 0, this one is 0, it's like a theta of NK plus theta of K, because this is going to be ignored. So the runtime of the whole algorithm is going to be theta of NK. This is the way you calculate the runtime if you have for loop, like a pseudocode algorithm. Every for loop, add based on the number of iteration. The first for loop, just doing it k times. The second for loop, the first for, because there are two for loops together, the first one call it n. For every number in n from 1 to n, you call it k times. So it means it's going to be nk. So that's going to be the runtime. Does it make sense? Clear? You can do it better because now in this table, you see how many zeros we calculated? You can do this algorithm also better and then remove deleting zero and calculating certain rows only, and then this is going to be better than this. But we are going to stop with this one. I say we are not going to move forward. So no, you cannot go from 1 to k. If you want to do 1 to k, you need to change everything. You need to change the, you can try, but you need to change the way that you write your algorithm. If you try and write it, and you see why you cannot do it. But if you want to do it, you need to change this for loop. Does it make sense? So the version, this is the reason we are saying this technique. This is called dynamic programming. Because as you can see, we program this one based on the like a table. It's like a sense of the table and doing all of this programming in like a sense of, we call this one, this way, the fully, we just recursively calculate this table. Recursive version, the fully recursive version that we do is called memoization. So that's the definition. When we say, if you see in the exam, they say use a memoization to calculate, you need to write this kind of table, all of this algorithm, their iteration version, because you just find it right and do it again and again in a loop. Does it make sense?
Yes.
Okay, let's go to the coin algorithm, coin problem. Just be ready because we need to discuss with each other and then write like a pseudocode for the submeeting. So does it make sense? Just listen really carefully so you guys can engage together because it's gonna be a quiz. So I will explain everything here, but you need to go and just write a pseudocode. So let's do this one. Okay. We say coin change. Coin changing actually is a really famous problem. So suppose we have n denominations of D1, D2 to Dn, where each Di is greater than equal, is a positive integer. So what we want to do, we wish to pay and what? We wish to pay an amount n using the least number of coins. Coins possible. So it means if I have the like positive number, like $1, $2, $5, and I want to just change my $10, I want to find the least minimum coin that I need to get. So there's some assumption. First of all, we assume that there is an unlimited supply of coin. Coins in each denomination. It means any of these coins is going to be unlimited. You can use as many as you want. So there are two things we are going to. There are two questions in this optimization problem. Guess what is the first question? So let's see. The first thing, how many coins? You say how many you want. What is that? We need to respond to this. What is the least number of coins? Okay. What is the least number of coins needed to pay and monetary so unit. So if I have n and I want to use coins, so how many coins? This is going to be there is called the value of n an optimal solution. This is the first one we need to respond. That's the first. Okay, let's see what is the second. Okay, I know, for example, I need 5 coins, but each coin is from which category? Are they all only like 1 or 2? Are they 5? So what is going to be the second one? Is going to be exactly which coin? Which coins? How many coins? Which coin? How many coins in each? From each category? Are the what? Okay. This is the optimal solution. Okay. So this is if I want to decide how do I define this one, I want to write it like this. This is gonna be, as I say, dynamic programming is like writing, like programming a mathematical format. As I get C, I, and J. What does that mean? It's the minimum number of coins necessary necessary to pay amount J, pay amount J using only coins instead D1 to DI. It means if I have J amount from which set, from D1 to DI, how many numbers I need to get. So, and then what is gonna be? I is gonna be between 1 to N, and J, because I is gonna be what? The number, how many numbers you want, you can get as many as you want. And J is gonna be between 0 and 20. Because, okay, I say, for example, the coin 1 to 5, I need, it makes $6, 6, for example, 6. And then J, which is gonna be the amount that we are generating, should be less than N. Does it make sense?
Professor?
Yeah.
What is the set? I can't really read what it says.
Set is like, for example, let's see, let me explain.
No, but what is it in the question or in the example?
So I have $10. I wanna like divide my $10. Set D is gonna be $1, $2. I have 5. This is the set. I have this number. Actually, we don't have $2. For example, if you consider this one in real life, you have only 1 and 5. D1 is gonna be this one, and this one is gonna be D2. It means for exchanging $10 with like this and like another number. So we have $1 and $5 in reality. So with this D1 is gonna be 1 and D2 is gonna be 5. As you can see, this is indices I is gonna be less than N, the number, and J is gonna be less than this 10. It means every time you cannot have 5 of, you cannot have 12 of $1 because it's gonna be more than N. So it means each J is gonna be less than N. Maximum is gonna be N. Does it make sense?
Yeah, thank you.
Okay, great. So what I'm gonna give you guys 5 minutes. So, okay, what do we seek? We seek for the solving the problem, we seek the value of what? We seek the value of C. What is it? I have what? How many numbers? It means how many coins for finding N. N is the real value that I have. That was the $10. Okay, I have $10. How many different like coin I need? Things that $1, 1 and 5 is coin. How many number of the coin I read it? We are trying to solve this one. Look at how many coins. So that's the one that we are trying to calculate. So this is the minimum number of coins necessary to pay this amount, which is going to be N, using this set of the coins, for example, we have. So tell me, okay, let's find the connection. So for finding this Cij, what you can get? Just think and then realize what you can get. What is some of the things you know already? So look at this, because I say, okay, I from 1 to N, J from 0 to N. So tell me some of the cases for here from these numbers, I from 1 to N and J from 0 to N. Just I will give you guys 5 minutes so you can think about it and let me. Does it make sense?
Yeah.
Okay, just think about it and then we discuss about it and then we write some one equation and one table and then you will calculate the next table and the pseudocode as a group. So just think about it first so it makes it faster. Sounds good?
Yeah.
Okay.
Professor? Hello?
Did you find it?
Can you scroll up to the beginning,
Mhm.
please?
That's the best thing I can do. So
Okay, thank you.
no. Okay. Did you guys get what's going on, or should I write this one and then let's calculate and then do the same? Does it make let's write it. Does anybody have any idea?
Maybe you start with 0.
Yes, yes, sounds really good. Because if I say, okay, I for j equal to 0, you see, for calculating this one, we have I from 1 to n and j from 0 to n. So if I have 0, it's $0. It means I don't have anything. So this is gonna be 0. If I wanna things that I'm gonna use that money to see how many more coins I need. If I don't have any money, I don't need any coins. So this is gonna be for any I between 1 to n. If j is 0, it's gonna be 0. Does it make sense? This is the first observation. Clear?
Yeah.
Yes.
Okay. So why do we do all of these things? Because so let me add something here. For all of these questions, so just okay, how many coins do we need from each coin category? How many do we need to answer the question? To answer the first, what we need to do, we create C from 1 to n. Okay, what should I do? Let me write it down. So let me do this one. I want to write it here, so it's going to be more this up. Sorry. So let me write it here. Optimal solution. And then I will add this one here to answer the first. We say what? We create a two-dimensional . 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - 2 - table. We say for memorization, we create a table, which is going to have this C from 1 up to all n, because we have IN. And then the other one, for J, we have 0 to capital N. So we create this one. So probably that's the reason we need to have J's. Look at C. We have for C, I, J from 0, because J start from 0. So we do calculate all of this one. So this is the first one. We say, okay, this is the first one. So let's do something else. So let's do it. What we do, we say, okay. So next, what we see, okay, let's say next. Notice that to pay the amount, now we want to pay amount J using only this denominations. So let me write it. Denominations from what? D1 up to all DI. If I want to go all the way to DI, so we have in general two conditions. What is that? Let's stop. Okay, I want to pay, let's, for example, $10. The first one, I want to use all these numbers. So, for example, 1 to 5 or anything. First of all, the first thing, use no coins of value DI. It means I know for any of them, so I go all the way, but I don't do DI. It means that I don't consider EI. So use no coin of value DI, even though it's a loaded. So the least number of coin needed sorry, for this choice is gonna be what? It's gonna be C I minus 1 for J. What does that mean? Why I use this one? Why? Does anybody know why? So no, not only brain using smaller. So things, if I said for any reason, I decide not to use DI, it means if I'm not allowed to, if I'm not going to use DI, for calculating, we use no value. So the least number, because we are going to calculate it. This is the what? That one was CIJ. CIJ was the minimum number. It means I is not allowed. So we need to go from CI minus 1. That's the reason we put it. If we know that I is not allowed, so the number calculated go from CI minus 1. Does it make sense? Make sense? Okay, sounds good. Let's do the second one. First of all, I think don't use any that font. Use at least. If I know, use at least one coin of DI after paying one such coin. If I use DI after paying such coin, what's going to happen? There are J minus DI. Why? Because if I know, for example, I have $10, now I say, okay, you need to use $2 for sure. Next time, I don't have $10 anymore. I have 8. So that's the reason if I use DI at least one time, the next time J is gonna be J minus DI unit, is gonna be left, unit, left, so K from denomination of what? The other. This is gonna be D1, DI. It means other than that, any of the others you want to choose, you don't have that J cost. You just have J minus DI. So is it better? I don't know what's going on today. That's the same thing that I do every day. Is it the case for every day or is it better? Okay. Let me write, see if it's get better. I don't know what's going on, to be honest, today. So I'm trying to be close to tablets, so just screaming, probably it's gonna be better. Okay, now if this has happened, the least, how about right now? Is it better? The least number of coins, okay, probably some 5. That's the reason, okay. The least number of coins that what? For this choice, what is gonna be for this choice? Is gonna be what? Can somebody tell me? That's okay, Annie. So I don't know what I can do, but yeah, try to make sure if you can join because of the quiz. So what's going to happen? Tell me if I know I use one coin DI and now I do have J minus DI. What is the number of the coin? How many coins do I gonna use? So how it's gonna be? So round down, I take 1 for sure. I have 1 because this number coming from one of them. If it's $2, $1, anything. The first thing is gonna be I put $1 out because this one number, because I already paid this one, and the other is gonna be what? It's gonna be I J minus DI because you don't have that one. Let me explain better. So okay, I have $20. I say the category of my DI is gonna be what? 1, 3, 7, and 5. Sorry, 7 and 8. 7 and 8. Oh, I said, first of all, for the first one, I say don't use like 7 at all. If I don't use 7 at all, it means all my C is gonna be C I minus 1. It means all of the things that I have. I minus 1 numbers. I don't have that one. I minus 1 numbers to J. That's the first thing because I cannot choose 7. That's the first one because the previous one, I was from 1, 2, 3, 4. We had 4 numbers. Now I have only 3. It means I goes to 3 only. It's gonna go to 3. 1, 2, 3 numbers. That's the first thing. For the second one, if I say, okay, you need to choose number 8 for sure. Use number 8. If I choose number 8, the number of coins, first of all, I choose number 8 one time. So I put it one aside because I already use it, plus 1. Next time I'm gonna calculate C, I say I can choose all of I but not all the i's, because I said remove 7, so it's going to be I minus 1, for example, if I consider both of them together. And then what? 20 minus 8, I already used the $8, so I don't have 20 anymore. I have 12. That's the reason I say J minus TI, because you already lose that one. And then it's $1 because you already used 1 coin of 8. Does it make sense? So that's the way we calculate everything. So now let's go and write it. So if I know this is the case, how can I write it? Now you want to write a table. The table entry, as you can see, this table have relationship with others, because anytime you find I and J, so the way the table is going to be like this. C, I and J, it's going to be minimum. So what's going to be? If I say there are two things. First, like I have 20 and I have this one, 1, 2, 3, and 8. I have two options. Use 8 or don't use 8. If I don't use 8 at all, so it's going to be what? I say, okay, consider don't use 8 at all. So this is going to be C of I minus 1, because I lose one of the coins, and J. You find this one first and say, okay, this time you don't use J, but next time use J for sure. If I use J, I say, okay, this is going to be one time because I use J for sure. And C what? Let me write it better. So this is going to be C, I, J again. I said so minimum. So you find which one is better. If I use 8 is better, or if I'm not used. So that's the reason I put minimum of what? C, I minus 1. If I use number 8 and J plus $1 between these two, plus $1, which means $1 is coming from 8. If I, not $1, one number, because it's coming from 8, from C what? I to J minus DI. This is the way you calculate the table. Does it make sense? Is it clear?
Yeah.
Okay. Okay, one more thing. First of all, if I is equal to 1, or what? Or J less than DI. So if I is equal to 1, it becomes C of 1 minus 1, it becomes 0. It's become go out of the table. Or J less than D, then one of, because if J minus D is going, this is going to be 0 of the values on the right fall outside the table. Does it make sense? Do you understand why it goes out of the table? You see, because put this one 1, if I is equal to 1, C 0, we don't have 0 in the table. So it's going to be outside, or J is less than D. This is going to be negative number. Table doesn't have something negative. It's going to be out of the table too. So that's the thing. It's convenient. It's convenient to regard such values, because it go out of the table, as being infinity, plus infinity. If anything goes out of the table, let's put it in plus infinity. Because why? Because the minimum of something with infinity, it's going to be infinity, because it's going to be the number, it's not going to be infinity. So this is going to be, since this is, so what is going to happen? So this is identify element with respect to the mean of range. So does it make sense? So for that, what we say if, so I say if I is equal to 1 or j is less than d1 or something like that, we put c of ij infinite. Let's solve one together, and then the other one you are going to solve it as a group and write the pseudocode for it. So let's write it together. This is me. If I say infinity, it means it's impossible. It is impossible. What does that mean? It is impossible to pay amount J using only coins of value D1. What does that mean? For example, if I have $20 and I ask you to just convert $20 for 50 coins, for coins of 50, it's impossible. You cannot change 20 with coins of 50. You can see I is 1, I only have one element, and then I do have this J is going to be less than this number. It is going to be impossible. You cannot convert 20 with 50. Coin of 50. That's one of the, okay. Let's write it. Let's write an example. The next one you are going to solve it, and then you guys write a pseudocode. Let's take the example. What is the example ask? I say, okay. Let me write the example next week, actually. It's going to be big. Any score, I have D1, $1, for example, D2, 3, D3, 5, D4, 6, and N is 8. It means I want to convert $8 with coin of 1, 3, 5, 6. And then I have only 4 coins. I know I want to pay 8. What is the least minimum number? So that's the question. The question is, if I have N as a number, if I tell you I have N, how many number of least minimum number of coin of this category? That's the question. I have $8. I want to see if I use coin 1, 3, 5, 6. What is the least minimum number of coin I needed? Does it make sense? So let's do it. Mm-hmm. No, it's unlimited. You can use them as many as you want. So let's write a table and then you'll decide. Make sense? Okay, let's do it. How do we write a table? I want to put I here, DI here, and then put J. Let's do it. J is going to be here. Okay, I said that I is going to be 4 because it says 4. 1, 2, 3, 4. Number 1, it means the element 1 is going to be which? It's going to be coin of 1. The second is going to be coin of 3. Third is going to be coin of 5. And the last one is coin of 6. That's the first one. What is the J? Let's consider. First of all, we say J is 0. It means we don't have any value. So if I don't have any, it's going to be all of them is going to be what? 0. How do we consider, how do we calculate this one? Remember, I wrote a formulation for this. It's like a C of ij is going to be what? Mean, first of all, what I say, you guys remember I wrote it. What did I wrote? Go and look at it. I say what? The first observation. What was the first observation? Here, the first observation was this one. We say C. The first observation was C, I, 0. This is the first one. I, 0 is 0. It means this. When J is 0, everything is 0. I find the first things in the table. Let's find a second. All of the other from the table too. We need to find it based on the formulation. Second, Cij was what was minimum of what? C, you remember. So okay, and it's not allowed to use I it's gonna be I minus 1 and J, and then it's gonna be 1. The next one is gonna be minimum with these two. 1 plus what? C of I, J minus B I. Let's see. How do you calculate? Okay, now I do have this number. J is gonna be what? What is J? J can be 1, can be 2, can be 3, can be 4, 5, 6, 7, 8. 6, 7, 8. 6, 7, 8. Because the n is 8, so J can start from 0 up to 8. So how do you find this one? What is that? C of 1, 1. How do you find C of 1, 1? Let's write this one. C of 1, 1. It means minimum. So this is going to be minimum of what? C, 0, 1 plus 1C, 1, 1 minus DI. Okay, so now I want to fill this one. I want to fill this number. So how do we calculate this? So, okay, C of 0 and 1. What is C of 0 and 1? I explain what is 0, 0. It means I don't have any coin. We say consider infinity. This one is going to be infinity. How about this one? So you see, if J is less than DI, what is DI? DI is 1, 3, 5, 6. It means this one, this number, sorry, this I minus DI, this one is going to be a small, it's going to be what I wrote. Okay, oh, sorry. It's going to be a 1 minus DI. This part doesn't exist, 3, 5, 6, but 1 minus 1, C of 1 minus 1, if I consider the first one, it's going to be 0. This one is going to be 0. 1 plus 0 is going to be 1. Minimum of infinity and 1 is going to be 1. So this is going to be number 1. And then we keep going. Now for the next one, how do you consider the next one? You're just doing this one. You need this C and just keep going and calculate this one. Because now you see how it works. Does it make sense?
Can we keep going just a little more on the table?
Sure. So I did this one. Let's do the second one. Help me to do it. So the second, what is the second one? I will write it here so you can see the table. So the second one is coming from what? I is 1 still. And what is J? J is 2. It's a minimum of what? C, I minus 1. 1 minus 1 is going to be 0 and 2. And then what is the next one? It's going to be 1 plus what? C is going to be 1. And this is going to be J, which is going to be 2 minus DI. Okay, so tell me how it works. So you need to consider, because this is DI, you need to consider all of them. What is C, 0, and 2? This one is we still no, because there is nothing we do, which is it's going to be infinity. And let's go look at this one. This is 1, and this is C, 1, 2 minus DI. Okay, there is two possibilities for DI. DI can be 1, you know, DI can be 1 or can be 2. Does it make sense? It can be 1 and 2, but if I consider DI to be the second one, I to be 2, it's going to be 3. 3 is greater than this one. This is become 2 minus 3, which is going to be greater. So I don't use that one, but I can use number this one. I can use this one. So it's going to be 2 minus 1. I can use this I to be equal to 1. It's going to be, this is going to be what? This is going to be C, 1. 2 minus 1 is going to be 1. C1, 1. I go to the table. I calculate C1, 1 is number 1. So it's going to be, this is going to be number 1. This number. This number is going to be number, this is 1 plus 1. I have, this is going to be 2. Between minimum of infinity and 2, this is going to be number 2. Does it make sense? So it means how I do it. Let's do it. Let's do it better. Actually, this is gonna be CI. So sorry. This is gonna be C of D of I, D of 1. So that's easier. So this is gonna be C of DI. DI was 1. 1 minus 1 CI 1. So let's do one thing. How about this one? This is gonna be minimum again. C of what? C of 0 and 3, which doesn't exist. 1 plus C of what? I is gonna be 1, J is gonna be 3, 3 minus what? D of what? I is 1, D of 1. So let's do it. I know this is infinity, this is 1. Let's go to the table. D1 is what? D1 is gonna be number 1. So this is gonna be 3 minus 1 is gonna be number 2. So it means C1, 2. Go to the table. C1, 2 is already 2. So it means 1 plus 2 is going to be 3. So this is going to be 3. And if you keep going, exact same thing is going to happen. You need the previous one. This is going to be 4. This is going to be 5. This is going to be 6, 7, and 8. Because I just do the exact same thing. You're just doing it. This is going to be infinity. And next time, this is 1 plus the previous one. This is going to be the way I calculate. Does it make sense?
Yeah.
Now let's do the second row. How do you do the second row? For example, let's do C, 2 and what? 2 and 1. How do you do this one? It's okay. Minimum of what is easy. C of I minus 1. 2 minus 1 is going to be 1. What is J? J is 1. C1, 1. And 1 plus what? C of I is 2. 1 minus D of 2. Okay, let's go back here. So D2 is what? D2 is 3. 1 minus 3 is a negative. As I mentioned, if this is the case, this is infinity. I just don't consider all the infinity. C of 1, 1. What is C of 1, 1? Is 1. So this is going to be 1. So I put this one here, 1. Does it make sense? Is it clear? Just keep doing it. Just putting the numbers. Do you guys understand what's going on? Why forgot?
Yeah, kind of.
So okay. Let me ask you guys to do this one. Okay, let's do C. Let's do this part. Let's do this one. C, I is what? 3, J is 1. Do this one for me. Just write it. Let's find it. What is that? What is this one? First, let me know. What is this C? Let me write it and then keep going. What is this gonna be? C of what? Look at the formulation.
Is it 0, 3?
No, it's I minus 1. 3 minus 1 is gonna be 2.
Yeah.
J is 1. So this is gonna be this one. What is the 1 plus what? C of what? What is I? I is 3. This is gonna be 3. J is 1. 1 minus D3. What is D3? Go back. D3 is 5. So this is gonna be a negative number. So this whole is gonna be infinity. Because this is whole, as I mentioned, if it's become negative, it's infinite. What is C21? Let's go to the table. C2, 1 is 1. So this means that this is 1. And so minimum of infinity on 1 is going to be 1. This is going to be 1, 2. Did you understand?
Can you just go over the minimum real quick? C21. How you did that?
Which one?
You know how the beginning of the equation is minimum C, and then you do
Here.
Yeah.
This is coming from here. If I do, for example, let's do the last one. 4 is I is 4, J is 1. Okay? Is it clear? This one is clear. This part?
Yeah, that's clear. Yeah.
So, okay, what is minimum? So what is this one gonna be? C of what?
3 1.
Okay, 3, 1. How about the next one? 1 plus what?
3 minus D1.
Why 3? It's gonna be
4. Sorry.
4. J is gonna be what? It's gonna be 1. J is 1. This one is J. This is I. This is J. So it's gonna be 1.
Is it 1 minus D4?
1 minus D4. Make sense? Is it clear right now?
Yeah.
Okay. And let's go to see what is D4. D4 is number 6. So 1 minus 6 is gonna be C of 4 minus 5. Can I pay minus 5 with $4? So it's impossible. I cannot use if I have minus, how can I use number? I don't have anything. My budget is minus. So that's, as I considered earlier, so if it's become minus, I will consider this one to be infinity. So it means infinity plus 1 is gonna be infinity. And the minimum of a number with infinity is gonna be that number. We have C1 in the table. 3, 1 is 1. So I can minimum of 1 and infinity is gonna be 1. Does it make sense? Is it clear? I think the person asked question. I'm not sure who was it. Is it better? Did you get it?
Yeah, I kind of get it now.
Okay, great. So if I keep going, so you just do this one. The first one is harder. Why? Because you just keep doing it, but the next one is become easier because you're just repeating everything. So if I do this one, it's gonna be like keep going. This is gonna be 2. This is gonna be 2. You need to calculate. This is gonna be 2, 2. So you just keep doing this one, and then you calculate this one, and then you're just doing these things, and then you see that's how it works. So the next one, I just don't write it. It's gonna be C1, and then it's gonna be 1, 1. And then we have 2, 2, 2. And then this is become 5, 3, 1, 1. And then this is become 6, 2, 2, 1. And the next one is gonna become 3, 3, 2. And then 4, 2, 2. Just doing this one, just put this one on calculator. Okay, what is gonna be like a question for you guys? For as the group, I'm just gonna make a like a group, like break room. So you are gonna work it together. This is gonna be the example. Let's consider I have only 3 coins. My first coin is number 2. My second coin is number 4. My third coin is number 5. And then I have n equal to 8. Just fill this table and take a screenshot and put it in your canvas. I will make a quiz. So this is DI. You need to fill this one. 1, 2, 2, 4, because I have only 3 number, 1, 2, 3, and then my cone is 2, 4, 5, and then J. What is J? J is gonna be number 0 all the way up to number 2, 3, 4, 5, 6, 7, and 8. This is gonna be number 8. I want to consider this one like this. Fill this one based on this. Let me bring it down and write the formulation so you guys have it in one page. So what was Cij? Cij is like mean of what? C I minus 1 J, and then 1 plus C I, then Gj minus Di. And then the first, I have another observation. Let's put it here too. I say, okay, Ci0 is gonna be 0 for all i's between 1 and n. That's another observation. And then Cij, if I is infinity, if I is equal and j is less than the 1. For example, actually this is the case. It's gonna be 1 or j equal less than di. If it's gonna be j, any of them, this is gonna be infinity. So fill this one, upload it, and the next thing you need to do as a group, write a pseudocode for it. Based on the calculation, how to fill this table. You remember I explained it here above. For example, we say, okay, for ij, for loop, you remember for this one, I say, okay, write a for loop. For this, start with this one. But how did you start? Like a for loop going 1 down. For example, for this one, you need to write, okay, for I to n, you need to just put this in a 1 first, like this one. You need to use this one first. This one, because you need to make this one first work. You need to find a lighter for loop for I 1 to n, Ci0 is going to be 0. And then do it step by step going down and write the pseudocode. So that's the thing. So let me put it here so you guys can see all of these things. Let me make a breakdown. Sorry. So you guys can join any of the rooms and start solving the problem.